Hello, ladies and gentlemen, and welcome back here on the industry stage at Formnext 2023. I tell you what, we are kicking off day 3 of Formnext 2023, and I can promise you can expect a lot of highlight, a lot of exciting expert insights, and we will start right away. So yesterday we talked a lot about the impact of additive manufacturing on sustainability, but we also saw repeatedly real applications in companies, which was really awesome. Today, we will take a closer look at challenges and opportunities in the industries, while we are also focusing on work and career, because today it's our official career day at Formnext. And we will start this third day with an exciting keynote on smart manufacturing, impact on productivity, sustainability, and on workforce in aerospace and defense. Let's welcome Mr. Nicholas Muehl, who is driving development at Boeing as Director Additive Manufacturing. Nicholas, I'm really looking forward to your insights. Stage is yours.
Thank you. Good morning, everyone. How is everyone doing today? My name is Nick Muehl, and I'm a director within Boeing Additive Manufacturing, and have the pleasure today to talk about additive and smart manufacturing, really two technologies that go hand in hand. And wanted to talk about really how are they working together and what is their impact on productivity within our factories as we're looking to scale additive, within sustainability, really important aspect of what we're trying to do within Boeing, and also within the workforce. As we're developing smart technologies and artificial intelligence, what does that mean to our workforce as we need to grow and scale and adopt the technology going forward? So my team within Boeing Additive Manufacturing is really focused on all things digital. So I have the privilege of being able to look at additive and digital technologies and how do they work together. And as we look at digital integration broadly, we have a lot of opportunities within the smart factory. How can we use data? How can we harness data to increase productivity within our lines, to increase the quality and the stability of our factories through the access of data? And when we have that in the context of additive manufacturing, it's a very data-rich process, as we know. There's a lot of insights to be had, but there's also a lot of learning in terms of how do we take a lot of data across a complex process and reduce it into a way that we can make decisions and help us with efficiencies and really take the technology and grow. And within the aerospace environment, not only can we integrate data for cost and schedule reduction, but it's an important opportunity to increase the quality of our products and the safety of our products through increased traceability and taking the data and contextualizing it for the technology and for additive. So taking a step back, we've had additive manufacturing, within this conference and seeing a lot of the innovations continuing to take place. But we've seen broad advancements within Industry 4.0. So over the past 10, 20 years, as Industry 4.0 has continued to mature, we've had a suite of supporting technologies developed. We have Internet of Things. We've got artificial intelligence and machine learning. We've got robotic and automation within our factories. As we've continued to develop these capabilities, they are all important technologies that we need to integrate together and harmonize. And that's where the challenge is smart factories, is how do you harmonize all of the data and all of these technologies in a way that can be efficient and help us within additive and the parts we're trying to make. Because ultimately, the parts we make on products is where that value is delivered. And our ability to integrate these technologies into a comprehensive manner is where we're able to then create efficiencies, whether it's cost or increased quality. So at the end of the day, they're on products that can benefit all, the lives of the people around us who use the products. And that's the aspect of that harmonization I wanted to talk about briefly. And what does that mean within my team and within the broader industry? So as we look at all of the supporting technologies, whether it's Internet of Things devices, whether it's robotics and automation, and how do we integrate that in a holistic manner, we're starting with data. Data by itself can be interesting, but it's difficult to take that and turn it to be actionable and make decisions. And in the world of a complex process like additive, you can get terabytes very easily of data, and it can be overwhelming. And the ability to take that data and translate it into meaningful information and knowledge so that you can start seeing connection points within the additive process. How does data from step 1 correlate to step 3, 4, and 5? And then your ability to interpret and correlate these relationships is where the power starts to form. And as you're able to take those insights and through current tools or advanced AI and machine learning, the power is going to be on the far right of this chart is the intelligence. You have clear, actionable correlations between data, and then you can take that for decision making in the factory. There's a lot of tenets to get there. In order to get accessible data, you have to have architectures and very thoughtful strategies in place to organize your data, structure it, and really decompartmentalize. We can't just have printers on a factory, then followed by subsequent equipment across your factory chain. The data needs to be all integrated in one place and contextualized. So we know exactly for a given geometry in a build, how does it relate to all subsequent tasks? Only then are you able to then apply advanced analytics and really put tools together so that engineers or technicians or anyone who's involved in creating an additive product can do their job better and help make decisions. And so from the broadest perspective, the ability to take data and be able to contextualize it within tools to make decisions is core to what we do. I was at the ASTM workshop on Monday, and a lot of the discussion was centered on an engineer could spend 80% of their time finding data and only 20% of their time for decision making. By putting together a smart factory framework and tools in place, we want to switch that paradigm. The ability to have that data at your fingertips and be able to work more efficiently. And that only not leads to productivity, and I'll talk about sustainability benefits, but how does that also impact the workforce of tomorrow? Now within my team, how does that look? As you've gone through, a strategy to integrate your data, put together a smart factory strategy, put together that framework, really what you have now is the integration of your additive process. Multiple steps, as we know, a lot of data, rich data created along the way. Not just the printer alone, especially with in situ data and the sensors and all the Internet of Things information. You can get gigabytes, terabytes, depending on your part. You also have heat treatment, you have machining and inspection, and the ability to integrate that data and automate it into a smart factory setting. You have that ability to integrate it into a really thoughtful, centralized database or a centralized location to do that harmonization from data to intelligence. We've taken the approach of having a broad architecture within Boeing Additive Manufacturing, so we can take this data, integrate it with engineering definition, the manufacturing and the post-processing, all the way through distribution, where you've delivered a part and you're getting data in the future. Now you're able to contextualize that and take all the information on the left, which are all these data opportunities on the screen, and translate those truly to the intelligence. And that's where you have the ability to apply machine learning tools to sift through rich data sets and have understanding that may not be obvious through the human interpreter. You can inform physics-based models to help anchor and validate, whether that be physics-based tools for simulation, trying to reduce your workload, whether that's trying to validate in situ monitoring, which we know can be challenging and complicated. You're able to integrate that all and have tool suites to help the engineer, help the technician, the quality operator be successful. As we're looking at that data integration, how can we use additive artificial intelligence in our workflows? How can we use that as an industry? I think as we're seeing continued offerings in this space, we start able to look at algorithms that can help mimic human tasks and decision making, but certainly not replace. At the human, the worker, the expert in the field is really critical to that decision making. And how does that impact what we need to do to make parts and deliver them? But what these algorithms can do is help us understand what? The data to intelligence integration. Understand why it's happening. When you have very complex processes, it's not always intuitive why something may have occurred. Either an issue in your print, or perhaps in heat treatment or machining, you had some sort of an issue. You'll be able to now look at that data and perhaps see relationships to guide something during the print actually was caused by a design feature. and having data to feed back and make those design solutions up front and prevent that from occurring. As we start developing, maturing the technologies, we really have the ability to control the process for production, stabilize it so we can continue to grow new applications, and optimize it for future growth. Because really within aerospace, it's all about repeatability and having a stable process that we can depend upon. And that data not only helps with our efficiency, but we build confidence in the process, feed that knowledge into our upfront learning, and continue to have that compound growth. We're able to understand and grow and have experiential learning that can feed back into the broader organization. Some of the powerful learnings we've had so far that will continue to grow is how we can use machine learning and the sensors from out the factory for predictive maintenance. Additive equipment can be complex. There's a lot of variables. Being able to predict the utilization of the machines, understanding critical key factors to operate the equipment, and really understand when you're going to be drifting in and out of predetermined limits to achieve the process that you've established through whatever development process you've achieved. Being able to have predictive quality, using in situ data, which has rich data sets that can either determine machine health or a lot of aspects, being able to interpret that into a interpretable data set where you have flags to say I may or may not have an issue, or perhaps even zooming in on data sets and saying I've had a localized indication that needs more attention. These are all very powerful tools that can be challenging to determine on your own with these large data sets. So just to give an example or some context of how we've applied these tools and technologies, within our Boeing Defense Group, we've been applying this to our satellite product line. And recently within our wideband global SATCOM, we've used additive to create products that were not possible before. So not single part replacement for cost, but achieving increased performance and capability that is not possible without additive. And as you're looking to increase the quantity of parts, we do certainly see achievable benefits in terms of overall cost reduction, but that overall integration of the tools is really seen on that bottom row here. As you're designing the parts, you're using simulation and digital twins to understand how do I improve it up front so it's successful throughout its entire fabrication lifecycle. As I'm manufacturing through print, you're getting feedback loops from the sensors themselves to understand how is it behaving, not for individual part acceptance, but also overall information to guide where we go in the future for these product lines. Going through quality assurance, tools to help us understand and integrate. And all of these come together to help deliver a part ahead of schedule and on time, but also to leverage increased pedigree and safety. As we're doing mission critical additive parts for aerospace, that is the utmost importance. And as we integrate these tools, that lets us achieve that in a more productive manner. Now touching on the workforce, what does this mean? We've seen in the news generative AI. What does that mean for the workforce of tomorrow? Frankly, for additive manufacturing, the workforce is central and key. These are tools to help us make decisions, help us interpret data. People perhaps may not have to do as much tedious work that a algorithm can automate and focus on really that high value add judgment and interpretation and decision making so that then we can have increased throughput on our factories. People are always going to be critical for this decision making. It's going to increase more time so we can look at some of these complexities of the process and continue to improve, refine it. And certainly not all things in additive can be automated. And I think this is something we all know. After print, we need to have complex machining, especially in aerospace as we're integrating with complex structures. We need to have that new continual refinement into the design cycle. So we need to really leverage these tools and work with them as tools in our toolbox that are going to make our jobs not only easier, but enhanced. And so we can continue to be innovative and apply really the creativity that the workforce can bring to our complex problem solvings and really focus on the challenging problems to make. As we're looking at the workforce development, there are some challenges and gaps. I think we need to recognize manufacturing is core to what we do within additive and all of the supporting processes. We need to continue to strengthen and promote the importance of this skill. We can't do it without a skilled manufacturing workforce, but we can take the opportunity to upskill the workforce, train individuals within all these tools and how they can help them do their job better. We're not looking to change the dynamic of how we interact on the floor together. These are going to be continued tools to help us over time and strengthen. We're going to continue to learn and release. Now, in the last few minutes here, I wanted to now talk about not just productivity and the workforce implications, but sustainability. There's been some good panels and discussions at the conference here about sustainability. I think intuitively, additive is already ripe for some sustainable benefits within product lines. It shrinks the supply chains. There's significant less material waste. But now as we look at the smart factory aspect and integration, we're able to now further strengthen the sustainability benefits to our products through reduced global emissions, reduced material waste, by now leveraging even further productivity in the workforce, or in the workforce and the workplace. There are two key aspects of sustainable manufacturing. The indirect, the smart manufacturing, as we make a part, are there opportunities to take out waste, opportunities to remove global emissions? And then there's the part produced itself. If you reduce the weight of a part, you have lower CO2 emissions on an airplane, for example. And these are both go hand in hand and both important. And by leveraging a smart manufacturing workforce and a smart manufacturing deployment, you're able to really look at these two and have a more holistic sustainability strategy. As we're looking at a life cycle of a part, there's a lot of opportunities where waste can be created or also waste can be removed by being thoughtful about the overall approach. So whether it's feedstock, can you recycle material? In the case of additive, recycling powder, both on the feedstock and throughout the factory process. Can we reduce waste throughout? All of these individual elements need to be quantified and characterized to tell and help us understand how do we optimize and design our process to remove waste and have the optimum understanding and design for sustainability so we can really improve what we do. Now to touch on a couple case studies. The first case study is an aft galley support 787 product. It's been deployed for several years now, and it's produced additively. This is something that we've spent some time on that previous chart looking at that whole life cycle. What was that impact when you quantify and characterize and measure all of these factors? What does that look like in the end product? And if you look in the top right here, the blue line is our baseline, the traditionally manufactured. When you have an additive solution and employ all of the cumulative savings and waste reduction opportunities we spoke about, you can see the drastic reduction in all of these water consumptions, energy consumption, CO2 consumption, significant reduction. And it really demonstrates the power of additive. And as we can harmonize that with a smart factory, we're going to continue to have those benefits. A second case study, looking at a powder bed fusion bracket. By taking advantage of generative design, we can meet the same form and function as the original design, which had a lot of material waste. We were able to cut out 1/4 of a pound from this application. When you start looking in aggregate, it may not seem like a lot on a single part, but when you start looking at multiple applications within an aircraft and you have that cumulative benefit, you have a significant reduction in CO2. So for this particular application, it had a 19% reduction in CO2 over the aircraft's lifetime. And as you continue to leverage these technologies, that's continue to grow and help us be even more efficient and thoughtful about the environment going forward. And as we're looking at sustainability going forward, and we look at the indirect and direct capabilities that it can offer, that really brings forward within industry the need to design for sustainability. And as you look at for both the direct and indirect benefits, it creates a matrix. You may have some applications that have a mixture of both indirect and indirect benefits. As you target the upper right quadrant here, that's the best of both worlds, and that's where we want to operate. But certainly as you're designing for sustainability and you have the underlying smart factory technologies to help you further reduce waste and increase efficiencies, you have opportunities to continue to be be thoughtful of our environments and look at either direct gains due to part optimization. How can you design a part that really benefits what we do from a sustainability perspective? And consider this overall quadrant here. The lower left here is an area where we would like to avoid. You're not having positive trades, either direct or indirect. But these types of frameworks, coupled with smart manufacturing technologies, coupled with design philosophies to design for this sustainability approach, are going to continue to help us make these decisions going forward in a thoughtful manner. And as you kind of look holistically, the central theme here is both additive and digital integration not only help productivity, but helps us make positive decisions for the environment, can help us integrate with the workforce of tomorrow and really go hand in hand. So it's a very exciting domain to be in. I think as an industry, we still have quite a bit of work to do together to continue to learn and refine and discuss at forums like these. So for that perspective, I wanted to thank you for your attention here. And I believe we should have some opportunity for questions, I believe.
We do. So thank you so much. Big applause for Nick, please, ladies and gentlemen. Okay, let me first address the audience. Any questions from the audience? Before I start asking, because I have plenty of questions. Sorry, Nick, for that. Very inspiring. I like the combination, to be honest, between productivity, sustainability, and workforce, because it's good to see that someone is looking at all these aspects, not only on a single one. Let me start with sustainability, because we finished your presentation with sustainability. You were talking about the savings you reach by using additive manufacturing. My first question would be, how do you calculate it? Do you have any kind of, like we heard yesterday, like a CO2 calculator? Sure. And the second one is, who is asking you to calculate it? Don't get me wrong, but who is giving you the motivation to calculate it?
No, excellent questions.
Yep.
So if you recall the chart lifecycle cost analysis, the LCA tool, there are a suite of software platforms that help you do this. And it is a lot of work. You have to break down the process to every finite step and ask really intentional questions and identify what data do you need. So you have to work with your supply chain partners. And these software platforms are helpful because you're able to actually quantify it and they guide you through the process. But it has to be very intentional. You have to be willing to get that data and bring it into the tool and validate it so you can trust it and build upon that. So these are the types of software platforms that help you design for sustainability. You need the data in order to make those decisions.
Okay.
The back end of your question, it's a central initiative within Boeing globally. How can we continue to embrace sustainability for tomorrow, reduce our global footprints? So going from the top, we want to integrate with that vision, and within additive manufacturing, we find that is the perfect opportunity, given it's already such a sustainable technology. How can we strengthen that further with these tools to help us make good design decisions? Because there will be some parts, perhaps maybe there's not a sustainable trade, just as every additive part may not be an ideal additive solution. You have to have tools to help us make those decisions.
Very good answer. Let me get back to the data at the very beginning, because I was asking myself, in the past I've seen a lot of startups dealing with digital twins, data streams inside additive manufacturing. For example, we had Nebumind, who are working closely together with Airbus, for example, in the aircraft industry. So are you developing all these data models and the data stream yourself, or do you need service partners and software developer from external side that you work with? How's that process working?
I think it's mixed.
Yeah.
Within aerospace, one, we just have to have that foundational development internally. How do we organize this data and structure it in a way, both internal systems and external, that complex supply chain? And if we're starting to look at the regulated aerospace environment, we need to have that core understanding of data validation and how it's structured. But that's certainly not something we can do ourselves. And so we partner with companies to help us, one, structure the data across the supply chain, across how we interact across companies. And then especially on the analytics side, we're continuing to see innovations in the marketplace where now that data is organized and structured, now it's rich for study. And that's where we want to partner with companies and see, where's the creative novel approaches to analyze print data, to analyze the integration across the board, especially across supply chains. There's a lot of complexities. Certainly, I think we can't do it ourselves, and I think the industry recognizes we need to work this together, especially within standards. There's a lot of need to have a standardized way of doing this together. Absolutely. Because if everyone's organizing their data differently, those interfaces will be more challenging.
That's one of the main challenges.
Yeah.
Niklas, time was running out. Sorry for that. I would keep on going with you all day long because there are so many topics to tackle. Thank you so much for being our guest today. Thank you for the inspiring speech. Nicholas Muir, ladies and gentlemen, big applause to him. Thank you, Nicholas.
Thank you so much.
Good success for the Formnext. So, ladies and gentlemen, before we keep on going, you can enjoy another 5 minutes of exciting highlights here from Formnext, but please stay tuned. The next speaker you definitely don't want to miss. Keep stay tuned and see you in 5 minutes.